All right, so we're continuing on in section 6.2. Remember to have your Z table and StatCrunch opened up. So what we looked at is we looked at being given some information about data and then working to find the probability that we see that. Now what we're going to be doing is looking at doing that backwards. So sometimes we want to look at finding percentiles. So just a quick little overview of what percentiles are. Percentiles means that you are greater than that percentage of people. So for example, if I said that I am in the 60th percentile for women's height, that would tell you that I am taller than 60% of women. Also, when you have a baby or something like that, what they'll do is that they'll tell you what percentile your child falls into. So for example, one of my best friends had a baby and the baby's head size was in the 95th percentile, while its body size was in the 50th percentile. What that means is that her baby's head was bigger than 95% of other babies, while its body was only bigger than 50%. What that means is that my best friend's baby had a giant head and a normal sized body, looked like a Disney character, completely cute, very healthy, looks adorable now. I'm sure I say that, and then I'll see you guys in August, and I'll be like, oh my god, my babies have huge heads and tiny bodies. But we'll see. So, for example, let's say that we want to find the height of a woman such that the probability that we'll see a woman shorter than her is 85%. So what we have to do is work backwards, and to do that, we're going to use the standard normal curve. We're going to use that Z-table, work backwards to find that Z-score that relates that percentile, and then convert that Z-score back into the proper units. So here's what we're going to do. I took a little clip of the Z-score table and put it here on the notes. So remember that these numbers are the Z-score. The numbers in the middle, though, here, are the probabilities. Okay? So what we're going to do is that we're going to try to find the number closest to 85% that we can. So when I look at the Z-score table, the number that I find the closest is 0.8508. If you wanted to do this one, that's fine. Now that we have the percentile we want, which is 85.08, okay, we're going to look and find the Z-score that's associated with that. So the Z-score associated with 85 percentile, or the 85th percentile, is going to be 1.04. Now remember, the Z-score is going to be our observation minus the mean divided by the standard deviation. You can also think of this as x minus mu divided by sigma. I kind of use them interchangeably. So what this means is that 1.04 is going to equal x, which is the woman's height, we don't know, that's what we're trying to solve for, minus 64, that's the average height, divided by 3. Now we need to solve for x, so remember, to do that, what we're going to do is we're going to multiply both sides by 3. Okay, so that's going to cancel out that 3 in the denominator, so we're going to have 1.04 times 3. That's going to give us 3.12 equals x minus 64, and we have to add 64 to both sides. So what that tells us is that x is going to be 67.12. Now, in math and in every class I've ever taken and actually in my day-to-day life, I just want to make sure, does that make sense? So if we draw a normal curve, okay, and we have 64 here, and we look at a woman who's 67.12, does it make sense that that would be about 85%? Yeah, it does. That looks good. If we got this answer and it was somewhere over here instead, I would say that that probably wasn't a good idea. Now, before we get to our last example, a couple things I want you guys to be aware of is that we can only use this if we have a normal model. So, for example, we could definitely use it on this one because it's normal. If we draw a curve over our data, we capture most of our data. However, this one is not. So we can't use the normal model for this. Can for this one, can't for this one. So for the next example, we're going to do these two ways. We're going to do them by hand and using StatCrunch to check our answer. So suppose that the number of smallpox cases has a mean of 147 and standard deviation of 18. Remember, another way that we can write that really quick is we can write n of 147 and 18. So what is the probability that we choose a country that has less than 130 cases? So let's see. First, I always start these by drawing a curve, or a better curve. There we go. And I always like to put 147. Okay, and then I always like to go one standard deviation above and below, and then another standard deviation above and below. So if I do 147 plus 18, that's going to go out to 165. And then if I do one below, that's going to go down to 129. And if I go one more up and one more down, that'll be between 111 and 183. Okay, so what's probably that we choose a country that has 130 or less? So that's going to be all these countries over here. So remember, to find the probabilities, you have to find the z-score first. So that's going to be 130 minus 147 divided by 18. We're going to round that to 2 decimal places. So that's going to give us negative 0.94. A negative z-score makes sense because remember, the observation we're looking at is below the mean. Now, the probability that that is less than negative 0.94 is, remember, now that we have the z-score, we're going to find that on our table. So negative 0.94 is going to give us 0.1736, or 17.36%. Now the next question is, what's the probability that we choose a country that has more than 130 cases? So what we're going to do again is look at that normal curve-ish, and we want to do the opposite. So we want to look at more cases. So how do we do this? Well, remember, this is going to be, let me give myself just a little bit more room. This is going to be 17.36%. What is this going to be? Well, these have to add up to 100%. So to find this one, it's going to be that 100% minus that 17.36%. So that probability is going to be 82.64%. Great. Before we move on, let's go ahead and check our answers on StatCrunch and just make sure that we're doing the right thing. So remember, to do this on StatCrunch, you're going to go Stat, Calculators, Normal. Don't forget, we're going to change the mean and the standard deviation. So our mean was 147, our standard deviation was 18, and we were looking at 130 cases. So let's see, when we plug that in, we got 17.2-ish on StatCrunch. Hey, that matches up pretty good with what we found by hand. Now, the probability that it sees more than that is going to be 0.827. That also matches pretty good what we found by hand. Now for the last one, we want to do an in-between. So, what's the probability we see between 130 and 150? So, remember, we have 147 here. What we're going to do is find the probability that we see 130 cases or less. This is right here. We already found that. Okay, so I'm just going to write that in. That's that 17.36%. Now what we need to do is we want to find the probability that we see 150 cases or less. It's always going to be less, okay? So 150 or less. So remember, we have to find the z-score first. So when we find that z-score, we are going to get 0.17, so I'm going to round it up. So now that I have the z-score, I'm going to find the probability that I see less than that amount. So let's see, that was 0.17, so I have to go down a little bit. 0.17 is going to be 5675. Okay, so what I found is that this piece will be 56.75%. Now remember, I want to find the area in between these two. So to find that area in between, what I need to do is take 56.75 and subtract that 17.36. So 56.75% minus 17.36% is going to give us, that is going to be 39.39%. Great, let's check that on StatCrunch and see if that works out for us. So remember, we're doing an in-between case, so we have to go to between. And we want it to go between 130 and 150. So when we do that on StatCrunch, we get 0.39.37. Awesome, super close to what we expected. That's great. Okay, so just a little wrap up. If you want to find the probability that something is less than, you're going to find the z-score and then just go straight to the table. If you want to find the probability that you see the observation or more, you're going to find the z-score, go to the table, find that percentage, but what do you have to do? One more step, subtract that from 1 or subtract it from 100%. If you want to find the in-between scores, you have to find the probability for both of them using the z-score table and then subtract the two. If you get this order messed up, it's not going to be hard. The reason is, if you switch these, you'll always get a negative answer, and you know that probabilities can't be negative. So just switch your numbers around, subtract them, and you'll get the right answer. All right, we're going to have a warm-up or kind of a wrap-up video doing a little bit more practice, so totally optional if you want to look at it. Go for it. If not, you should be good to go on the homework.